The tech billionaire Elon Musk is saying his Neuralink company has successfully implanted one of its wireless brain chips in a human for the first time. He made the announcement on X, his social media platform, saying the procedure happened on Sunday. He says the subject is recovering well and that initial results show a promising neuron spike detection. Mr. Musk says the product has been given the name telepathy, and the plan is for it to enable control of a phone, computer or almost any linked device just by thinking about them. Several rival companies have already implanted what are known as brain-computer interface systems in humans after tests were carried out initially on monkeys. With more, here's our North America correspondent Peter Bowes.
What Elon Musk's Neuralink is trying to do is what a number of other companies have been attempting for quite a while now, and that is essentially to create a brain-computer interface that will allow a human being to carry out an action through thought alone. Now, it involves implanting a number of microchips into the brain that connect to a part of the brain that is responsible for movement intention. It has the effect that wirelessly it can send a signal to an app that can interpret a person's intentions. It sounds very futuristic, but according to Elon Musk, he says in a post on X, he elaborates a little bit, saying that this device will enable control of your phone or computer and through them almost any device just by thinking. He says initial users will be those who have lost use of their limbs. It seems they're targeting people with debilitating neurological conditions. Now, it should be stressed that this study is in the early stages. His company was given the go-ahead only last year by US regulators to carry out this human trial, which is in the safety assessment stages. And clearly there is a lot to assess over the following months and years, question mark over whether this device will still be operating as it is designed after 3 months, 6 months, possibly a few years, and the results will be scrutinized very closely. So with that in mind, realistically and practically, it could be several years, if indeed it is shown to be successful, before this kind of thing is available on a wide scale.
Let me show you first of all what the device looks like. And as Amy said, all we have is basically tweets at this point about this. But this is what the device looks like. And this is a device then that would sit in a certain area of the brain. So that's the interface that we're talking about, the brain-computer interface. It's then connected to something that sits in the chest, which is essentially via Bluetooth, giving off signals to devices, a smartphone, a mouse, things like that. So the idea is then to connect that particular part of the brain via the device we just showed you to the environment, specifically some of these devices around them. It's not the first time, maybe the first time for Neuralink, but these brain-computer interfaces have been implanted before. I had a chance to talk to the CEO of Synchron, which is another company. They've been implanting these devices, specifically to ask him about what these devices are. Take a listen.
What is a brain-computer interface?
If you can get a device that can detect and interact with brain activity, which is all electrical signals, then you can potentially restore that component of the brain.
So what that basically means, let me just show you to your question, Jake. If you have a device that's sitting in a very specific part of the brain, this is a part of the brain that controls motor function. The device sits there, and then basically over time the device learns what is the electrical pattern in the brain when someone thinks to move a mouse forward or move it to the right. It starts to learn that. After a while, the device knows enough that when a person simply thinks about this, and this is a person who has quadriplegia, for example, when they simply think this, they can actually create movement on a computer screen. That's basically where we are right now. The brain does cognition, it does sensation, it hears, it sees. This is motor. This is motor function that could potentially be restored to some extent for someone who doesn't have it because of ALS or quadriplegia.